And these were the questions that we were doing yesterday using logarithms. So these are called exponential equations because the x is in the exponent. The first two we did were called logarithmic equations because the x was in the logarithm. And the main questions on your test on this unit will be, can you solve log equations? Can you solve exponential equations? The majority of your marks on your test will be questions like this. There are more than one way to do these questions, okay? What we're going to do when we solve each of these is go through the classic method of solving. The classic method of solving an exponential equation, if it's on the calculator part of your test. If it's on the non-calculator part of your test, you'll probably have to use your powers chart and get the bases the same. But if it's on the calculator part of your test, you are going to use logarithms. And what you're going to do when solving with logarithms is, if you can, you're going to simplify. Nothing we can simplify in the first one. And then once you feel like you've simplified as far as you can go, you are going to take the log of both sides. And it doesn't matter which log you choose. You can choose natural log, you can choose log base 782, although that would be annoying because you'd have to write 782 every single time. Most students just choose either the natural log or the common log. The reason we take the log of both sides is to use our log logs to expand to get the x out of the exponent. This one, right away, you might notice, hey, I can bring that x out in front. That is our goal, to get that x out in front, because now you can get x by itself by dividing both sides by log of 4. And as you were working in groups yesterday, I showed some of you that if you type this into your calculator, so I've got log of 12 divided by log of 4, get my answer. On your calculator, there's a store button. You can store that answer as x. And once it's stored as x, you can go back to your original equation, which said I had 4 to the exponent of x. And if I push enter, if this is equal to 12, which it is, then I know I've got my answer correct. Just really nice. Nice to be on a test, be able to say, oh, I can quickly check, is this answer right? And feel confident to move on. For B, I mentioned in the last question, if you can simplify things, or sometimes it's easier to tell students, if you can get the power by itself, your log laws will be easy. It's not wrong, and some students will take the log of both sides right at the beginning, okay? But if you can simplify, and in this case, I could divide both sides by 3 and get 12 equals 2 to the x plus 1. If I can do that early, my life is going to be easier in solving. I'll solve it the long way too and show you what that looks like. But I divided both sides by 3, and now I've got my power by itself. I have an exponential equation because the x is in the exponent. So I need to solve by taking the log of both sides. And that allows me to bring this power out in front. And since there's more than one thing, when you bring that power out in front, it has to be in brackets. Because this log of 2 is going to get distributed And we have successfully got the x out of the exponent. So that's what our log laws do. Log laws solve for exponents, and they allow us to get that x out of the exponent. Now that that x is out of the exponent, we can get the x by itself. It's just a matter of, right, I can move the log 2 over to this side, leaving me with x log 2. And to get x by itself, I now just need to divide. And once again, we can take out our calculator. We can enter this in to check log 12 minus log 2 divided by log 2. We get our answer at 2.58. I'm going to store that as x. And I'm going to check. On the original equation, I had 3 times 2 to the exponent of x plus 1. If this is equal to 36, I know that I've done it right. It's always nerve-wracking, right? Push the enter button. If it's wrong, it means I've taught you completely wrong all year. It's a little scary. Now, often in these questions, they'll ask you to round to 3 decimal places, so your final answer, you will write 2.585, rounded correctly to 3 decimal places, as your final answer. And then the most difficult of these exponential equations are ones where there are x's in the exponent. But before I do that, I'm going to re-look at B. Because sometimes you'll see the x in the exponent and you'll be so excited to use logs that you might take the log of both sides really quickly. And one of the reasons I encourage you to get the power by Excel is that there's a common mistake that happens here. Students are so excited to get the x out of the exponent that they move it out too soon. Your log law that lets you move this exponent out in front only works when that exponent is to the entire thing inside the log. Right now, this x plus 1 is just an exponent to the 2. It is not an exponent to the 3. So bringing it out in front would not be using the log law correctly. So if you took the logs early, as in this situation, you would have to use first your log law of multiplying. And multiplying inside a log is adding. And then you would be allowed to bring the x plus 1 out in front. This question is very similar, except now you're going to move over to this side. You have log 36. I'm going to subtract the log 3. Can you see when you distribute, you'd have an x log 2. I'm going to leave the x log 2 on this side. I'm going to move the other log 2 to this side. And then I could get x by itself by taking this whole thing and dividing by log 2. Typing that into your calculator will give you the exact same answer as the other one that we did. And maybe you can see, right? Put a circle around that. You go. Okay. I'm going to put a circle around that. What's your log law for subtracting? Divide. 36 divided by 3 would be 12. So they are the same thing. But you're going to find if you can divide first, if you can get your power by itself first, it'll make your log laws a little bit easier. Because if you don't, this step to this step is often a mistake because you want it, you're so excited about bringing that power out in front, you do it too soon. You can only bring a power out in front with a log law if that power is to the entire thing inside the log. So when we do it from this step to this step, that x plus 1 is the power to the 2, and the 2 is the only thing inside that log. But initially, the x plus 1 is only the power to the 2, not the power to the 3. So you're not allowed to use that log law at that point. Sometimes all the extra log laws are unavoidable. We're going to do two more, one that is in the textbook and then one that I'm going to make up for you. Part C. Oops. Part C, I'll write it out again, is 3 to the x plus 1 equals 6 to the x. And what's different about this one is there's x's in the exponents on both sides. It's still an exponential equation. We're still going to solve this by taking the log of both sides. And since this exponent is to the entire thing, we can use the log law and bring it out in front. And here you'd have to distribute. And now we have x in more than one place. And while you were doing these questions yesterday in your groups, reading over the examples, when you have an x in more than one place, this question here is basically like solving something in grade 9. But instead of nice numbers, we have logs. If I translate this back to nice numbers, you will know exactly what to do. So instead of writing log, I'm just going to pretend this number's a 3, this number's a 3, this number's a 6. If you had 3x plus 3 equals 6x, could you tell me how to solve that? You'd be like, yeah, that's like some of the easiest math that I know. I just combine my like terms and solve for x. That would be easy. This is basically the same thing, okay? This is something times x plus something equals something else times x. But it's a little bit different because here, how easy is it to combine your like terms? You subtract 3x on both sides, right? And you would get 3 equals 3x. That you could do mental math, no problem. When I subtract the x log 3 on both sides, our mental math isn't there. It's like, I don't know what log 6x minus log 3x is equal to. I don't have the skills to do that mental math in my head. And so what we do is something similar, except we leave the mental math part undone. You really need to subtract log 6 minus log 3, but you can't do that. The same thing as doing that would be factoring out your x and just leaving it as, I don't know what the answer is, but I'm going to just say, it's log 6 minus log 3. Right? Here I could do it. 6 minus 3 is 3. Can you see that if you didn't know, you could have left it as, I don't know, but I'll just leave it as 6 minus 3, and hopefully someone else can figure that out for me. And what this allows us to do, if we factor out the x, so anytime you have more than one x in a log equation, You won't be able to do the mental math, but you'll always be able to factor out the x. Once that x is factored out, you can get the x by itself by dividing. And again, we're going to check on our calculator.
Sorry for the interruption. Whoever has card 4, please buzz the office. That's whoever has card 4, please buzz the office right away. Thank you.
I'm going to type that into my calculator. I'm going to get x is 1.585, so to 3 decimal places. And if I want to check if that works, I'm going to store that as x in my calculator. I'm going to go back to the original equation, and since there's x's on both sides, I'm going to type in 3 to the x plus 1. And I'm also going to type in 6 to the x. And if these answers are the same, then I know that I've done the question correct. And they are to every single decimal place. Okay, so log equations and exponential equations, like the ones we've done, there's going to be probably 4 to 5 of them on your test, counting for about 15 to 20 marks out of your 50. That's a big, 40% of your test is just on 5.7 on these two ideas, solving log equations, solving exponential equations. Okay, we're going to do one more, the most complicated exponential equation that I can think of is if you have x's on both sides and you have a number in front. If this is the situation, you can take the log of both sides. On the left-hand side, the exponent can come out in front, but on the right-hand side, it cannot. The reason it cannot is because that exponent is just to the 2. So we have to use our log law first, saying multiplying is adding. And then what we're going to do is the terms that have x's, we're going to put all on one side. So I have my 2x log 3. I'm going to have an x log 2 on the other side, which I'm going to subtract. And I'm going to put all of my terms with logs. So I have a log 4 here and a 3 log 2. And I'm going to move my minus log 3 to the other side. So notice all of the terms that didn't have, that had x's, which would include this one and that one. I moved all of those to the left-hand side. And all of my terms that did not have x's, which was my log 4, my 3 log 2, and my minus log 3, I moved those all to the other side. Once you get your terms with x's, you can factor out your x, leaving you with 2 log 3. Okay? Common mistake here, if you take an x out, you're not left with 1x. The x is taken out, you're left with the 2 and the log 3. There's a lot of writing of the same thing over and over again. we can divide. And as a result, we can check to see what this is as a decimal. So I'm going to go to my calculator. Scroll up. See it? I have log of 4 plus 3 log 2 minus log 3 all over 2 log 3 minus log 2 push enter, and I get 1.574 to 3 decimal places. And I'm curious to see if this is correct, so I store it as x. I say, what was my original equation? On the left, I had 3 to the 2x plus 1. And on the right, I had 4 times 2 to the x plus 3. The answers are the same, so we know we've done it right. When you look at the question in its entirety, right, looks like a lot of math and a lot of algebra, but the majority of the steps are straightforward and very predictable. Solving exponential equations follows the same rules every single time. So for those of you that like following rules, log equations follow the same rules every single time. Just have to get good at following those rules, taking the log of both sides, knowing your log laws to expand completely, getting your x's on one side, numbers on the other side. If you have more than one x, you have to factor. Then you get x by itself. It's an ugly looking number, but you can type it into your calculator and get the solution. So questions to circle first. Example 3 are 7, 8, 10, and 12.